So here's a actually functional 4-channel audio switch that I talked about in one of my earlier videos. And I've made a circuit so that you just press a button and it iterates through these channels in stereo. And I've got a little power converter chip, a flying capacitor converter, which will take any 5-volt wallboard supply and convert it into plus and minus 9 volts so this thing can run. We have an output enable switch. And actually, this thing goes both ways. You can multiplex one of 4 outputs to 1, or take one and go to one of the 4. Not bad, huh? Here's my audio switch hooked up to my tower of power. I have all my hi-fi devices. Before, I'd have to take each one of these inputs and plug them into the amplifier manually. Now I just press a button. Alright, so today I want to show you a little project that I actually completed quite a few months ago, but have just now got around to videoing. This is a newer version of the function generator amplifier. If you remember this video, I made a prototype PCB of a function generator amplifier that will basically beef up the output of any function generator. And this thing had quite a bit of issues, like the heat sink wasn't close enough. There was all sorts of gain issues, like the bandwidth wasn't very good. And so I've slightly improved everything, made it a little more ergonomic, made it actually electrically function the way it should. It's the same size heat sink. But now we have a AC-DC coupling switch, which will basically allow any DC offset on the input to be either transferred to the output or be isolated. So if you have a function generator that might have some permanent offset that you don't like, you can turn that off or you can have it on. There's a nice big power switch here, so you can just turn it on, turn it off. You still got 2 LEDs, you got your power supply input. You have a B and C jack or a screw terminal bus bar thing, a socket for the op amp or the smaller op amp. You still have an offset trim knob, which is very useful, and your current limiting resistor, which you can obviously swap out for a smaller value if you think it's getting too hot. Pretty standard stuff, really. And it comes on this beautiful blue PCB. And of course, it runs on these 24-volt power supplies, if you remember, wired up to give plus and minus 24 volts. And it performs basically the exact same, well, almost very, very similar to the old one, except I've optimized the gain. The gain is now a little more usable. This one was a little too low for most function generators anyway. You weren't reaching clipping when you maxed it out. This one will get you a lot closer. Bandwidth isn't actually all that great. It's probably, in its current configuration, you can change it. In its current configuration, it's probably around 500 to 800 megahertz, and not at full swing either. At full swing, I think it's a little bit lower than that. But nonetheless, I don't think they actually make these out there. I mean, they do, but they're stupid expensive. They're like $800. But as far as kits, I don't know of anyone who makes these. I'm going to offer these things now on my website, which I'll link in the description. I'm also going to link a build blog where I have all sorts of little projects that maybe don't warrant a video, or maybe they were in a video, but maybe you want to see more details on the schematic or the design. And so there's all sorts of good stuff coming. There's going to be all sorts of little kits you can buy too. This is just sort of the flagship of them. So go over there, poke around, see if you like anything. This is, you just buy a PCB. These things are actually quite expensive because these op amps cost over $30. And of course, these are all name brand components. None of these are, knockoffs or anything. The only thing Chinese here is probably these PCBs, and these are great, these JLC PCBs. Okay, for those interested, I'm going to go over the schematic and some of the changes. In fact, actually, this PCB is an older version. Some of the resistor values have changed. I've tried to split the gain between these two op amps a little more evenly so we get the best bandwidth. All the decoupling caps are mostly the same, except they've reduced the 680 microfarad down to a 220. The 680 seem to be a little too big. It's kind of unnecessary. I've added a AC or DC coupling, so the input will either go through a capacitor into the input or through just a switch, just a wire, and it will just be DC coupled all the way. And there's a bleeder resistor here. It really doesn't do anything except discharge the cap if a charge builds up on it from static or whatever. And there's your offset trim as before, and these are non-inverting gain stages. These op amps are configured as a non-inverting amplifier, so the ratio of these resistors determines the gain, but it's always 1 plus whatever that ratio is. So in this case it's 3, and then that is 2.7, and so between that you get a gain of around 8.1 through the whole thing, and that will basically, at least for 24 volt power supplies, that will basically cover all your needs. That will bring you pretty close to clipping for at least for a lot of different function generators. The really low output ones might struggle. Of course, you could increase these values, but remember, if you increase those values, your gain bandwidth product goes down and your bandwidth may suffer. Although I have found, after utilizing this circuit quite a bit, that it actually seems to be slew rate limited. So it's actually how fast the op amp can change. It has nothing to do with the gain. It's just the nature of the output stage in there. So it's pretty hard to do, to go from DC up to 1 megahertz and expect that to work perfectly at, tens of watts. But we can try with these kind of state-of-the-art op amps in a simple circuit. So yeah, that's the gist of it. They're not a whole lot different than the prototype, but they are, in my opinion, a whole lot cooler, a little handier too. They're not as awkward as just the big... Actually, these things work great as coasters, these PCBs, because they're just like this random square. But yeah, that's a side note. See you all later.